All right, so it's time for the lightning talks. First guy on stage, Helio. So give Helio a big round of applause.
Oh, you can take. I need to talk. Was a catch? I just wrote my name for people to just go down and write as well. So sorry. But what I'm going to talk is about this guy here. It's a small webcam attached to a small Raspberry Pi. It's running Python and publishing directly on the Twitter. That was my own slide. Everything else I'm going to show is just a code and result, which is basically that's the code that runs on Raspberry Pi. I'm using Pygame. I run it every 5 minutes to acquire some image. This is just to find, it takes some agenda that's in the format of a date, comma, time, the name of the presentation, who's talking. Then every 5 minutes it lights up here and take a picture and publish directly on Twitter. It's a very small code. I have that on a GitHub, my GitHub. I forgot to add information about that, of course. And it's basically just to light up the camera, in it, take the nice picture format here, get the image, and publish directly on Twitter. Not a big thing. Get here to not show your credentials. I have enough file. That's good to not show, right? And that's it. Let me see if we can take a look. That's basically the result. My tweets. So you can see my head here, big head in front of the camera. It's taken automatically all the things. It tries to write the name of what's happening here. For all the speakers, there's some bugs, so sometimes it comes empty and doesn't explains properly what's coming. And let me try to see if I'm connected. Can you see? You can. Very simple, and that's the script, the format it takes. Just read and try to fit the time, the current time, if it's in the gap. Oh, okay, it's there. Of course, if you overlap the time, it's going to take the first match and go forward. If you ask here to, it's on a cron tab, but you can PyCon. Then it lights up. You can see it's that's the moment of the shame. So yeah, 80 minutes, then it lights up, start, get the image, and publishes. So all the big heads are there now. Thank you.
All right, so next person up, do we have a Henrik here? That civil disobedience with Python. That's the next guy. Big round of applause.
Precis.
All right, that didn't show. All right, I'm gonna do a very quick talk about civil disobedience using Python. This is me, if you like to chat about this civil disobedience later. I come from Värmland. It's the red municipality there. For those of you not from Sweden or from the ignorant parts of Sweden, Stockholm. In Värmland, we have Värmlands Trafik. It's the public transport company there. And at the start of this year, they removed several countryside stations. This has been discussed since I was a kid. And it's been opposed by many commuters and basically everyone using the trains. People who want to go out into the countryside. Someone got annoyed, and if you combine that, removing the stations with the worst possible Wi-Fi ever, someone decided to send a message. This is the commuter's pass. You have this little card, like here in Stockholm. You go to a machine, you charge it with a 1 month commuting. What do you call it? Yeah, you pay some money and you can use this to travel. But you don't use that when you actually get on the train. You show them this receipt, a little paper slip. Like, okay, it's actually valid, this card. Trust me. The person who got annoyed thought that this was very silly. In 2007, the digital era, you look at the paper slip, you make me use this card in your very slow, stupid machine, and then you don't even use that to verify that I paid. It must be a better way. The frustrated individual mentioned before, going by the moniker infuriated traveler, he created the package Värmlands Trafik. It's a nice Swedish pun. It's a simple image manipulation library for generating counterfeit receipts. So this person, he scanned receipts, extracted the digits, and using very simple NumPy operations on the grayscale image matrix, he modified these and made it possible to generate counterfeit receipts. And the person stuck this behind a Flask web app to generate and deliver these receipts. And as such, the civil disobedience is almost done. You have to deliver this to the public as well. So using Tor and Unix virtual boxes to maintain an invisible front. He created an anonymous Gmail account, a GitHub account where he deposited the code so he could deploy it from there. Registered an AWS account and spun up a T2 micro instance. Deployed the Flask app there with a Let's Encrypt certificate, registered a free domain, and you're done. So what do I want to say with this? With great power comes great responsibility. Python equals superpowers. You know that, right? I hope you realize the power that you have available at the tips of your fingers. You can affect social change by coding, make a difference. So what happened? Did they resume traffic at the stations? No, they just gave every train warden a portable reader. But still, you can't win them all. An improvement, at least. It's not as silly and inane as it was before. They made a move towards the digital world, so something was won. Thank you for listening.
All right, thank you, Henrik. Next up, I will ask Dimitru to come up. Python to Erlang library. Big round of applause.
Hello. Well, you can see you well. So, hello everyone. Today I'm showing you the library. I made it before this summer. It still have things to do, but it's usable right now. You can already. So imagine you have Erlang running in your company. This may happen. This is quite rare language, which is popular in telecoms. It utilizes multi-core CPUs and clusters, makes possible to write your application in a scalable way. And some companies have a mix of Erlang and Python. So the question was, the problem to solve was to make them interface and speak together. So this library was born. This library creates an Erlang node on the network. So you create I will show a code in a moment. It registers on Erlang network and becomes an Erlang node. You could speak between the nodes transparently, do RPC calls, send data and messages. So let's look. I have a documentation as well here. I probably have to zoom a bit. So how Linus Torvalds says, talk is cheap, show me some code. There is some code I have in examples. So this is the basic how I begin. I import right now it supports Python 2 and G event, but it's very similar to async.io, which I will do as soon as I have the use case for it. So it's still the same approach. So I create a node, I give it an IP address and a name on Erlang network, and I give it a cookie, which is a simple password to encrypt the communication between two nodes, and do a start. That's it. After this, my node becomes visible on your Erlang cluster. And it's not just Erlang, it can be any language based on Erlang. It can be Elixir, it can be LFE, it can be Joxa, it's some more languages. They all run on virtual machine of Erlang and they share same technology of network communications. So when I do this, it becomes visible, it works. So now, how to make nodes see each other to join cluster. In Erlang, when some nodes are running on network, they need to address each other first before they connect. When they connect, they share all the information, they start seeing the whole group of connected nodes. So in Erlang shell, I do netadm : ping. And I say the name of node and IP address where I know it is. After this, they become connected, they start seeing each other. I can also send messages in this form from Erlang shell. I just say node process name and the node address and send hello. It will be delivered to my Python application. To call something from Erlang, I can do RPC calls. I can say which node. I can say module and function, module name, the full module name and the function name. And these arguments will be passed to your function. So this function is in my library, it prints to screen. So I start on one terminal, I start Python application, the example you've seen above, just this, nothing more. And on Erlang terminal, I start Erlang and I run this, and hello world appears. This is implemented through a remote execution process. So I simulate running process on Python side. There is a module on Python side, it's transparently started. I can send the reverse. I can send from Python to Erlang. So I tell who is the receiver, the name or process identifier, and I form the message. A tuple with some numbers and Erlang atom, which is similar to Ruby symbols. It's in turn strings, which are their own value. So you can form atoms, you can send normal strings as well. They will be delivered to Erlang side to process with this name. This is similar as well, but by process identifier. You can register processes by name in Erlang. That's why they can have names or they can have process identifiers. You can do from Erlang, you can create Python objects and make them exist, not die garbage collected. They will be registered on Python side. So for example, I want to do some longer calculations. From Erlang, I want to create some Python object in memory and let it do something and remember something and refer to it later. So then I do RPC call and create my object, I think. Yeah, well, I need to inherit from process class. It will automatically register self on Python side with this name, and it becomes accessible. So then from Erlang shell, I can send to this name, hello, and it will be delivered. So it will drop to my inbox in my class, which is like, you see 10 lines of code. Half of them is comments and printing. And this is more advanced topic. I can also make my Python object behave like Erlang generic server. It will run in the endless loop. It will collect messages. It will do some reaction on incoming messages. It can also reply back. And the good part that when you do RPC call and something crashes, the exception will be delivered across the network and you will see it appear on Erlang side. So that's it. That's the library. It's usable now. It's not complete because I need some use cases. I need some tests for it. And you are welcome to try it if you have any kind of Erlang node running on your network. So it's on GitHub here. And as well, all of you are welcome to visit our Erlang meetup, 19th of September. You can find it on meetup.com. We will have a Python plus Erlang talk as well. Not by me, but by a different person. That's it.
Nice. Nice. Thank you, Dimitro. Next speaker should be Åke. We have Åke, yeah. Mycroft.ai. All right. Big round of applause.
Whoa. Okay, cool. New. Yay. Okay. Hi. Oh, never been this nervous. This is Mycroft. It's a small device similar to Amazon Echo or Alexa. It's basically a voice assistant. It runs an open source stack. And it's under heavy development, but moving forward. So, why is it cool? Well, it's open source, it's modular, it's very community-driven, it's quite cute, and it's all Python, at least on the client. So, this is the very user-friendly representation of the software. Simple as that. So what makes this a bit different from other solutions is that it has a local wake word recognizer. So it basically won't call anything outside of the local computer before it knows that you really want to say something. It uses a cloud-based SET, a local TTS that's speech, text to speech, and speech to text. So when it's gotten a sentence from the speech to text, it sends it to an intent parser called adapt, and adapt maps the sentence to a skill, basically. The skills, it's user-created, mostly small applications. It can be getting weather data from SMHI, or it could be starting playback of music. So a skill, basically it contains an init.py. It contains a couple of directories with dialogue, intents, which is resources for the intent parser, which determines which skill should be called. So a simple short skill. This one will look for two keywords. The Python keyword and the rules keyword. So basically any combination of Python and rules in a sentence will be mapped to this function. And to just, oh nice, it works. Check it out, it's kind of cool. It's way better than I make it sound right here. We got a web page, mycroft.ai, GitHub page, and a nice friendly chat. Thank you.
Is it limited? Link data. All right. Thank you, Åke. Next speaker is Andrew. He has a talk called Linked Data Microservices. Big round of applause.
Thank you. Hello. My name is Andrew. I'm doing a PhD at KTH, and we work with linked data and semantic web. And today I want to talk about triple stores and how they're different from relational and non-relational databases. First, quickly, what is a triple? Triple is just 3 statements, and the key idea that is different from, say, graph descriptions is that both the first part and the second part are URIs. So every node in this virtual graph, so to speak, has a URI. And the benefit is that if you do it right, all the data globally across the whole internet will not have any clashes. So you don't need to synchronize data, do data warehousing, etc. Second most interesting property is that the properties, or as they're called predicates, they also have a URI. So there will be no more case when you have 2 JSON files having a name key, which mean different things. There are standard definitions with standard URIs that describe most common properties like names, surnames. Google uses RDF for describing shops, cafes, etc. The best part of it is that you can describe an arbitrary complexity using it. For example, for describing something like this, you would need to spend a lot of time doing relational data modeling, or you would end up with unstructured JSON in MongoDB that will break once you want to introduce some new dependency. Why do we care about this? So as Tim Berners-Lee is defining, we need to improve the quality of data on the web. And just plain HTML doesn't cut it because it was primarily designed for humans. And JSON doesn't come far because it doesn't describe what is the data you're talking about. You can just describe, you can just provide the data itself. And until very recently, there was a dark corner of semantic web that nobody cared about except academics, until 2012 when some people got together and said, well, we can fit it somehow into JSON so that the web-friendly people don't say no to it. Here is some RDF programming in Python. I just create one single triple saying that Bob is interested in Mona Lisa. And very small demo. Right, I already ran the code, so perhaps I can just increase the font. No, I can't. It's a serialized JSON LD that you can parse, and once you parse it with proper tools, you automatically get a graph representation. So you actually don't care in what JSON structure the data comes. It can be in different formats like turtle, etc. Back to the slides. And you might be asking, okay, good, but how do we use it for microservices? There are a few specifications, the primary of them being linked data platform, that allows you to define how your services describe RDF resources, which is just a fancy name for any entity your REST service serves, over HTTP. And the core idea there is that if a resource has an identifier and that's a URI, you can do a GET request on that URI of that identifier and you'll get the resource itself. There are a few more specs that dive deeper. For example, SLC is more interested in tool integration for legacy services. So if you deal with enterprise, take a look at that. I think my time will be up very soon, so questions? Yes?
Is this the sort of thing you see in the beginning of every single SVG file? Like, is RDF used for SVGs, for example?
No, so RDF can be serialized in XML, and that's primarily been this way. This is the reason why it's very broken right now, because a lot of companies like IBM parse RDF with traditional XML parsers instead of parsing them into a model. But I don't think that...
Oh, so RDF is not necessarily XML?
Not at all. It's just a model to describe graphs on URL steroids, so to speak. Sorry for not being very scientific.
Where can you give some examples of where it's actually used today?
So Wikidata, which is the data part of Wikipedia, serves almost all the data. So you can go to wikidata/wiki and refer to that entity queue and the number, and you'll get the machine-readable description of the Mona Lisa article with all the items like year of painting, who painted it, described in machine-readable format.
Well, thank you.
Yes?
So I understand when Google started using this data more, so a new ontology, schema.org.
Absolutely.
Does that actually connect much with the rest of the linked data web, or do we just have a lot of separate shards of linked data?
That is actually a very pertinent problem. Google thought that all the ontologies defined by scientists were bearing too much overhead. They were focused on reasoning, etc. But Google just wanted to give some tool to people to describe declaratively. And they just abandoned all the things that existed. But if you're interested, you can look at DC terms. This is what Google theoretically should have used. But if you want your search rankings, you probably should go for schema.org. Yes?
Is there a central repository for entities?
No, it's actually in discussion of the last topic, in the last group of APIs that I've talked about. Sorry. Hydra. So they're talking about the need of this, and also there is a format for validation, like competitor to JSON schema, but much more powerful, that it can look at which entities you link to that link to something. So you can say that a truck with a certain engine can never have more than X number of wheels, this kind of thing. And they're thinking of single repository of shapes. It's called Shackle, SHACL, if you're interested. And there is also a meetup group in Stockholm called Swedish Semantic Practitioners, if you're interested. Shameless plug. Yes, thank you.